Ready. Welcome to B-Sides, Rhode Island!
First one ever, first time that Paul and I have ever thrown a conference, so
if it sucks, we can use that as an excuse.
yeah, if it sucks, if it sucks, it's Mike Perez's fault.
Yes.
I want to welcome everybody here. Thanks for coming. Today's going to be the first day. We're going to be going from 12 to 5 today with 5, 6 speakers, however many we're going to get like that. And then after 5 o'clock tonight is, what are we doing tonight?
Scar event tonight. It starts at 7:30-ish. If you need transportation from here or directions or anything, come find one of the volunteers. We're wearing the white shirts. Not all of them are covered in coffee and beer. That's just me.
By the end of the night they will be.
Yeah. So we're ready to get started.
And the other things to look for, volunteers are wearing the yellow lanyards. So that's, if you see somebody wearing one of those. The only other thing is we want to ask Spring, come on up, Jack Templin.
Thank you. Hey, I just wanted to welcome everybody here. And we are thrilled that Rhode Island has its own B-Sides now, and we're even more thrilled to be hosting a day of it. Real quick, where you are right now is BsidesRI. We're a startup accelerator. Twice a year, we take 12 to 15 very early stage startups and give them a little bit of money and a lot of mentorship for 3 months. We're between periods right now. We actually just closed applications. But I'm pretty confident that if anyone here has a security or privacy company that they want to talk to us about, that we would make an exception. Again, I just want to thank you guys for being here today.
Thank you.
As you guys know, that these conferences can't happen without the sponsors, so we definitely thank all of our sponsors, including Spring today.
Let's get on with it.
All right, so our first speaker.
Yeah, go ahead. I'll get on with it.
Our first speaker is Charlie Eriksen, all the way from
Iceland.
Came all the way from Iceland just for this. So I don't want to hear any complaints about travel or anything. Charlie is a security analyst at CCP Games in Reykjavik, Iceland. He specializes in white box application reviews, mostly for web applications. He has a background in quality assurance, which eventually led him to focusing on the security aspect of quality. In spare time, he likes to poke fun at WordPress plugins.
Thank you, everyone. So just before I get started, if I start being too quiet, just yell at me, throw a shoe at me, whatever. And I just want to find out.
Oh, we have a microphone for you.
Really?
Yeah.
Wow.
Serious business.
Let it?
There you go.
There we go.
One of those audio outputs.
Go ahead, Charlie.
All right, so everybody can hear me now?
Yeah.
Excellent. All right, so just before I start, I want to figure out how many in the room right now do some sort of application security, just by show of hands. All right, and how many have sort of dabbled in it and would like to find one of these in random code? Excellent. All right, so as Patrick said, I'm from Iceland, Reykjavik, Iceland, small city on the coast of Iceland. And I live in this city. If you ever go to Iceland, there's a very important thing to know, and that is the Green Line. The Green Line is downtown Reykjavik in its full extent, and it's where you'll find all the bots. So if you go down that street, you'll be excellent. Yellow arrow, no, orange arrow. That's where I work. And this is what I work on, and there's actually more to it than this. We just launched our other game, but I work on a game called EVE Online. It's a 10-year-old game, which proves itself to be a nice challenge because it's such a old piece of wonderful magic. In my spare time, I like to hunt bugs, and this is how I see myself a lot of times looking at especially WordPress plugins. There's really no winning against these monsters, so that's what I like to do. So for today, the presentation I put together is basically about the sort of the process and the technique that I've been using for this sort of project I've been doing for about the last year. And there's 5 wonderful steps that you go through, and then there's a bunch of auxiliary stuff that's kind of interesting, so we're going to go through that as well. The goal with what I've been doing and this presentation is really to take a large amount of code, because that exists all over the place, and then find as many vulnerabilities as you possibly can, because there is an endless supply of them. And you want to spend the minimum amount of time you have to find each one of them, because you don't have endless amounts of time. So that's the goal. And the way it really came about is that I was trying to figure out what am I going to spend my time doing to learn all of this stuff. And at the time, Google Code Search was just about to shut down. And all of these people have been going, oh, we can find, bunch of vulnerabilities by just putting in regex queries into Google Search and find SQL Injection, all these things. But that was shutting down, so I couldn't do that. GitHub just launched their own sort of search as well, which is pretty neat. And you can do the same trick there. But this guy called Nick Canero, he put up a post a while ago in 2011. How to find vulnerabilities in the ghetto. And he sort of made the point, well, two major points, is that if you look at especially open source PHP projects, you are able to find a lot of vulnerabilities for two reasons. One is the barrier to entry for PHP is inherently low. And that is one of the major points of PHP when it was originally developed. It was basically made for newbie to mediocre programmers, and that's a rough way of putting it. To be able to code something easily, sort of in a prototype manner. And then when you have open source projects, in a lot of cases, especially if it's like one or two people, there's a very small amount of oversight over the code. There's not good quality assurance practices in place. So he thinks you can find a lot of vulnerabilities looking through that code, and that's what I set out to do. Now, throughout the presentation, I'm going to be having two kinds of slides. One is the white ones, like this, and the other one is the dark one, where it's really two parallel presentations. So the white one is really the theory behind what I've been doing, and then the black ones are the actual results and the application of this technique as to how it relates to WordPress and the work I'm doing there. So look out for that. Anyway, the problem that this technique is really trying to solve is manifold, but one is that you have a lot of code out there. If you join a new company, especially one that hasn't necessarily been doing application security or had a security program in place before, you have large code bases and they're not going to be secure in any way. And if you want to try and actually review those in any sort of depth, it's not going to be possible. So you're going to have to find a way to cover the most ground in the least amount of time. And you have to consider what is the cost of each vulnerability you find, because you have a limited amount of time and you're not going to have any budget. You're going to have other priorities for doing things. And then what are the higher risk vulnerabilities that you can find and eliminate from your code base? And it's really about making sure that you get the higher level of improved security that you can out of the time you're able to put into it. So that's what this tries to solve. And going into this, you have to sort of think about what are the items that you're going to try and solve. And when it comes to vulnerabilities, I think you can classify them into two kinds. One is systematic vulnerabilities, which are things like SQL injection and cross-site scripting, where not only can code review and manual and automatic review catch these things, but in a lot of cases you're going to have framework level support for actually dealing with this. And then there's the design and business logic issues. Those inherently a lot more difficult to deal with because you have to do code review and manual testing to catch it. No automated tool is going to catch it for you. That means you have to understand the application you're working with to actually deal with them. And this process mostly will be able to catch the systematic vulnerabilities because those are well understood and they are not necessarily unique, where the business and design flaws, they end up often being more specific to the application you are working with. And you have to really have a domain expertise with the application you're working with to find these. So we're not trying to find business logic flaws in any way. There is a nice side effect of looking a lot of code that you will often stumble into them, but that's not the priority. And it's also not to be able to get a list of all the vulnerabilities necessarily in a nice formatted document. There's going to be a lot of code you have to read through, and only like 1% is going to be actual vulnerabilities. And You're not going to be looking for the absence of mitigation necessarily. For instance, if you have a CSRF token you insert into a form, looking for the absence of a piece of code can be hard given the fact you have little context often. But we'll look at how you could potentially do that. The testing techniques that you'll be using for this, there's really two types of techniques. One is black box testing and the other one is white box testing. Black box testing is when you're running the actual code and you're poking at it with either a browser or your favorite tool. You don't necessarily have inside knowledge of how the application works. So it's really a black box. You have no idea what's going on. Where white box testing will generally assume that you have knowledge of the application, the inner workings, and most often you'll also have source code. So you can review the source code and base your review of the application based on that. And a lot of people fall to either side of these in terms of how they prefer to work. In general, there's always a sweet spot as to how you approach an application review. So being somewhere in the middle is always nice. And there's kittens there. So just listing the pros and cons, I'm not going to go through this in any depth. The big problem with white box is that often you'll have a lot of code and it will take time to go through. But on the other hand, given the fact that you have all the code, you will be able to review it more in depth and be able to pinpoint the most critical areas of the application where you need to focus your time. And black box, while it will cover most of what you'll see in actual attacks, there is the problem of special application code paths that you're never going to be able to cover because you have, when your discovery phase doesn't cover those necessarily, you're going to not be able to test them. And that's a problem. I really like this quote from Wendy Naylor, that basically black box pen tests are just testing a level of security for obscurity, which in many ways can be true. So that's why I tend to go with white box testing more than anything else. And then you also have to think about your return on investment for doing a review. If you go into a company that hasn't been doing application security or any kind of security in a while, you're going to find a large number of applications. A lot of them are going to be legacy applications that nobody really understands, and you're not going to have time to actually go through all of them and review them. Certainly not in any sort of depth at all. So you have to consider not only what you do not know about the environment you're working in. So if you do not know the full extent of the applications a company deploys, you don't know where to look for the risks and what you don't know, you're not aware of. And you also have to understand what is your vulnerability tolerance. If I'm reviewing an application that's an internal application only, am I going to be looking for cross-site scripting, for instance? Most likely I'm not. I'm going to be looking for command execution, SQL injection, those sorts of things. And it comes down to what is most likely to be discovered, and it's also what is most likely to have a big impact if exploited. So you have to understand, given the context of the company you're working with, and its tolerance to security flaws, which are always going to be there, how to spend your time and where. So you have to understand that. And you can make a funny graph of this, and it really comes down to this discoverability of a flaw and the impact it will have if exploited. Often you'll want to start by doing a review of as many applications as possible, finding the easily discoverable vulnerabilities that also have a high impact. At some point, you're going to have a small list of those, and you'll start dealing with exploits that are hard to find but have a high impact. Also, easy vulnerabilities that have a low impact, like cross-site scripting in many cases, unless you're Google. In that case, you'll have a lot of hard exploits to find that have very low impact. But at that point, when you are at Google, you have to care. So you need to think about what are the vulnerability types and classes that you want to address. And that feeds into how you go about doing this. And it really comes down to you have a limited amount of time, and that means money. And if you don't have money to do things, you're just going to not do anything. And that's not good. Yeah, totally. He was really nice. All right. So the technique I've been using is called, and I've seen, like I've tried to Google this term, and I've found very few results on it. But It's referred to in most places as the candidate point strategy. And what it means is that you're looking for candidate points that could have a vulnerability. And that is points with side effects and known vulnerable code patterns. And then backtracking that code to see whether or not a user can reach that code and exploit it. And I found it to be the fastest way to identify a lot of vulnerabilities, given the fact that you are looking at the most critical points in the code more often. There's a lot of different strategies you can use. And this book, The Art of Software Security Assessment, is basically the Bible. So if you care about this sort of stuff, read this. It's very thick though, so have a nice vacation or two and read it, and you'll enjoy it, hopefully. All right, so 5 steps to do this. The first one is you have to figure out what are the applications you want to assess. There's a bunch of different things. You can either have in-house applications, which any company is bound to have a million of, or public projects. I went with plugins, and those work out nicely, especially because they tend to be indexed and they tend to be publicly available, and a lot of people will download them without even caring about what they do. So there can be all the backdoors in them that could fit in, and people will still download it. So it's a good way to go. And then you just have to obtain a source code. In the case of WordPress, I wrote a small script that basically just crawls the whole thing and sourced on my local drive. So I downloaded a couple of tens of thousands of plugins and start going through that. I'll put this script up on my website at some point when I get back to Iceland, so you can have a go as well. Then you have to understand the target you're working with. In the case of WordPress, you have to learn PHP. Then you have to know what sort of vulnerabilities you need to look for. OWASP Top 10 is really good for that. It will have most of the vulnerabilities that you will find. And then you have to learn the framework and sort of the points with side effect, the functions with side effect that you may run into. Because if you don't know what to look for, you're going to come up empty-handed. And then it's a good idea to also look for commonly vulnerable code patterns. Especially an example might be a SQL injection vulnerability. You can often look for the SQL query in and the concatenation in the language you prefer and look for that. In terms of PHP, there's a really good list on Stack Overflow. The link is really badly colored though. I'll put up the slides later. But there's a list of different functions that you can look for. It's things like code inclusion, command execution, code execution, and another one that's WordPress specific is the WordPress database object, which gives you access to the database. And that one is always a lot of fun to look for because people assume that when they use the framework, everything is fine. And it's not. Next step, once you know what you're looking at and what you're looking for, you need to find code to review. And what you'll end up doing is that initially you'll look for the higher risk code paths. So that's anything with command execution, code evaluation, things like that. And you'll find different ways of looking for that in the code through usually a grep tool, a code search tool, something like that. And you have to determine what the most important functions are. And there's a bunch here, just examples. The one I really like is encoding and cryptographic functions. Very few people know how to use cryptographic functions at all. So people will just encrypt a static value and assume it to be good. It's often not. So you can find a lot of gems using that. And once we have all these different ways of searching through code and finding functions that could potentially be misused by the developer if he has no clue, that will be your candidate points. And that's really an iterative sort of step you have to take to look for new ways of finding this code. These are some examples, and they're really simple. And it pains me to put them up there because there's really no skill to this. But if you were to run these bunch of regexes on a code base that's any sort of large and it's PHP, you're probably going to find a lot of vulnerabilities. So that's sort of the sort of regex queries I used. And what you end up with, in this case, in Sublime, is a bunch of code, and this will usually be like tens and thousands of results that you have to sort of sift through and look at. And you have to build up sort of the mental capacity to look at the code maybe in about 5 seconds, the lines that are relevant, and see whether or not you want to spend more time looking at this code, or if it looks to you like the developer actually knew what it was doing. And in a lot of cases, you'll see that it looks completely fine, and there's nothing to really look for here. But in other cases, you'll actually find that there are things to look for. And when you find a piece of code that looks interesting to you, you'll want to review it and test it. That means when you have a piece of code, you need to read more of the code that is sort of adjacent to it. When you have done that, you need to go and test it. And usually when you do this, any sort of vulnerabilities that are easily discoverable will pop up at you really quickly. As you start reviewing more and you have fixed more things, it's going to be harder. But when you see them at a glance, you'll want to test it. So I have this screenshot again, and in one of the cases, one of the files that popped up on me is this one. And at a first glance, it might look exploitable because it always uses the get parameter. But when you actually look at it, it's not necessarily exploitable. For details, I'm not going to go into. But you're going to look at a lot of code like this and try and evaluate at a very quick glance whether or not this is something you want to spend more time on. I have a bunch of examples for vulnerabilities that you can find in example WordPress code. I don't know whether or not it's easy for you guys to see this on the screen, read it. But can anybody see what the vulnerability is here? It's not actually a SQL injection, and it's a good catch, but WordPress enforces magic quotes. Magic quotes in PHP escapes any character that could be exploited into a SQL query, so you can't actually escape out of the quote, unfortunately. Who was that? Yeah, so the MD5 part here is, so this is the procedure that resets the password for a user. And what you see is that it'll take the login name and it will pull out an activation key for that user. But then it will actually go ahead and just never use this, and it will make a new hash value, which is deterministic for the user, and then compare that. So that means that we can actually, when we have identified this line of code, which is very simple, just look for MD5 usage. Then you'll, first of all, be really scared that people actually write this sort of code. And then you'll write 6 lines of code, which will take a username and a user ID, which is all you need to actually access a user account and escalate the privileges. And it will generate the URL you need to submit to get access to a admin account. Another one here, you can ignore the second line for all intents and purposes because it doesn't actually do anything. And then there's a vulnerability here. Sorry? It's actually just any file inclusion. Yep, it can be a local file, it can be a remote file. In this case, there really are some details to, so yeah, it's include require you can look for, and it's kind of cute. Anyway, in this case, there's a bit of detail to the second function that it calls, and it actually is that it will do a check whether or not the path you give it leads to a valid file object. As it turns out, in PHP, if there is an object on a remote FTP server, that will count as a file. So you can give it an FTP path to a file you want to include, and it will actually execute that. Another example. Any ideas? All right. All right. It's a SQL injection, and so if you look at it, you can see that it's basically just concatenating a user-defined variable down at the end, and you can effectively, without any sort of messing around, just put in more SQL queries, and you can fetch data out of the database. How am I doing at time? Yeah, I'm good. All right, another funny one. This one is slightly more complicated. I'll give you a hint. It has to do with file disclosure. And especially take note of the fact that there's two different query string variables it takes in, but notice how it actually uses those in the end. It's not cross-site scripting. Any other quick ideas? We have a winner. Paul over here. Yes. So actually what happens is that, and yeah, this is the way, so file get contents will pull any file of a path, and you can, in that case, then output it. Anyway. So the interesting thing to note about this one is that there was, as Paul said, there's two different variables it takes in. One is the FN, which is the file name, and then there's a file. They can be completely separate. So in this case, what it was looking for was a PDF file in the FN file variable. And then once it validated that it's a PDF file, meaning you can't export it necessarily, it will go ahead and it will use the file path to actually take a file. Now in this case, I can put in just a random file name variable, and then I can provide a path to the WordPress config, and I'm going to get that output to me. So that's a funny one. Anyway, once you have found a bunch of different interesting code paths, and you have found a bunch of vulnerabilities, you might have a bunch of different vulnerabilities, but what's next? It's great to kill bugs, but at the end of the day, you have to prove and you have to improve your capabilities as far as securing an enterprise or a project. And you have to then take into consideration, based on the vulnerabilities you've found, what is the risk of these? Is it maybe a legacy application that is so buggy that it's actually a big risk to a company to run it? Then you also have to figure out if it is more recent code, is there a reason why these vulnerabilities have been introduced? Is there something I can do with the development team to assure that they don't introduce these sort of risks into the code base again? And then is it likely there will be more of these vulnerabilities that you haven't found? And if you think there might be more of these, find out how to find them. It often comes down to a bit of clever trickery with regexes to find all of these spots. And then find out if there's a way of mitigating these vulnerabilities on a framework level or throughout the whole application at once. Because the more time you spend looking for these vulnerabilities, you're wasting time if you could mitigate them overall on a more simple level. And then you need to figure out how are you going to improve the time it takes for you to find a vulnerability. And it also comes down to, are you close to the risk tolerance of the application that you're looking at? Because if you're spending time on an application where you think the risk of running it is lower than the amount of time I'm spending on it, and thus money, you probably want to move out into another application and start looking at that, because it's going to be more risky to your company. And you also have to figure out, is there any unknowns in the application that I need to look at? And whether or not there's other areas of it that you might want to look at. And if at some point you think you have found all the most, the more discoverable and high impact bugs, maybe it's time to move on. So in this case, with the WordPress plugins, I found all of the vulnerabilities that I'm going to be, that I showed you just previously, and all the ones I'm going to be mentioning here. I found this using this methodology. I submitted them to a vulnerability program run by Secunia. They have a vulnerability program. And what happens is that you submit it to them, and they coordinate disclosure with the vendor, and then they thank you, and they put your name on the site, which is nice. And then the data I'm going to be showing you was based on the data they have on their site. However, the download numbers I pulled manually. I found vulnerabilities in 24 plugins. Collecting all of the download numbers together, you get about 2 million downloads. And in all, between the 24 plugins, there were 66 vulnerabilities. These are all the plugins and the amount of downloads they have. Often what you see is that the higher download plugins tends to be more secure. That's not always true though. There is a company that tends to buy a lot of WordPress vulnerabilities. So the sort of, the amount of vulnerabilities in higher download plugins tends to be lower. But you can still find them, definitely. Like the bottom one, that one was really neat and actually not that easy to discover. So, in terms of the vulnerabilities, you have a lot of SQL injection, unfortunately, even if WordPress does offer ways of mitigating that on a framework level. I was quite surprised to find so many file inclusion vulnerabilities in the dataset. Turns out they are common after all. Security bypass is an interesting one because they tend to be sort of logic flaws more than anything else. So business logic flaws, things like that, or even information disclosure, which is always funny ones. And it really comes down to when finding security bypasses, you're not actually looking for them, but you stumble into them randomly, which is a bit sad. And cross-site scripting, I didn't actually look for them necessarily, but you'll still run into them all the time. In terms of the time to patch, you have really two different classes of vendors. There's the ones that actually care, and then there's the ones where they don't care until Secunia or whoever is coordinating the disclosure will tell them to hurry up. The interesting thing is that 6 of the advisories that was published did not have a patch at the time, and it took about a month for a vulnerability from it being found to it being disclosed. It was about a month. So, some of the sort of project that I've been doing, there's a couple of challenges that I sort of took on afterwards. And one is, as we discussed, how do you find the absence of a mitigation? In a lot of cases, for instance, with cross-site request forgery, when it comes to WordPress, you have to explicitly turn that mitigation on, and it has to be done on every single form. How do you find the absence of that? Is what I was kind of thinking about. And some frameworks are secure by default, which is nice, but you can't expect that out of a lot of frameworks. So I actually wrote a small script that took all the code bases I had, and it looked at every single project and whether or not in any file in that project it had any of the functions that actually either implicitly or explicitly will include a CSRF token. And the interesting result was that there's a lot of plugins that don't, and that leads to vulnerabilities. So I found over 2 weeks or so, I found 30 plugins with a total of 14 million downloads that were vulnerable to cross-site request forgery in a way that could either escalate privileges or do a persistent cross-site scripting attack. And you'll see that they have a lot of downloads, each one of them. I set myself a lower limit of 100,000 downloads. Otherwise, I would be spending years on this. And it was interesting to see that the average plugin that had this vulnerability was about 500,000, which tells me that it's generally not something that developers to consider when they develop the application. Another one is finding vulnerabilities at a faster rate than doing manual audits. It would be interesting to have a process where you have the constant stream of code from a source code repository and then run different regexes on it in real time as they get checked in, and then get alerts based on that. There's a couple of different ways of achieving that. And it really requires you to have the understanding of the code you're getting in and then what you want to look for and create some alerts based on a threshold that you can actually deal with, to have these brought to you at a rapid pace so you can assess them. What I ended up doing, and I unfortunately don't have anything to show for this, is I set up Splunk and I took a Word small script that will basically pull out any kind of change list from the WordPress plugin repository, and it will download the diff and it will put it in through the regexes, and then will send me a mail if I actually get any sort of hit on a regex that is extremely likely to be vulnerable. It's kind of fun. If anybody's interested in doing this, have a go at it. It's a lot of fun, so I would definitely encourage that. Anyway, so coming to the end here, the presentation so far has really tried to cover the ways that you can use even grep to uncover a lot of vulnerabilities. You will often be able to uncover these even using simple regexes, because a lot of the code that you will find to be vulnerable to systematic vulnerabilities will look the same. Because an interesting thing is a lot of example applications and books will have these code patterns and they're inherently vulnerable, and people just replicate what they read. So you can definitely find a lot of vulnerabilities. And it really comes down to reviewing the most critical code paths for things you know to be potentially vulnerable, and then go over it at a rapid pace and find as many as you can. And yeah, given the fact that I'm good on time, let's have another vulnerability. This one is fun. Who's that at? Excellent. Yes, this is a remote file inclusion. And what happens here is that you have an array of default values that is eventually used to be included, and then you merge the post array with the default array, and you end up getting the absolute path to be included. And you can absolutely get a remote file inclusion. And this is one of those functions you don't really think about actually looking for, but are definitely interesting to look for because they will often be used in very terrible ways. And yeah. All right. Any questions? So the question was, after WordPress, what's my next target? I had a couple of different things I've had a small stab at. One is collecting a lot of APK files from Android stores and unpacking those and looking through that code. And the other one is things like Joomla and Drupal. What I generally found with, I think it was Joomla, the framework actually enforces good coding practices in general. Where with WordPress, it tends to try and really focus on compatibility with old versions. Drupal and Joomla really enforce the framework mitigations that it offers, and is not afraid of actually dropping support for insecure ways of doing things. So it was also looking through the vulnerabilities already published on those platforms. There's a lot fewer. The Android thing, it's an interesting challenge to look at because you can still get a lot of APKs. I think I have like a folder of a few gigs. But what are you looking for exactly? That is really the question, because there's a lot of novel sort of attacks against Android applications, but how do you identify them easily? That is where the challenge comes in. And it's an interesting thing to look at, and I would encourage anybody to have a stab at it. So the question was iOS vulnerabilities, and if I've been working with them. And no, I looked at it, and as far as I can tell, actually getting the binaries out of the iOS files takes a lot of tampering with a actual running phone, and getting it out of memory, which is too much work. So I haven't looked at that. So the question was whether or not I used any tools to find vulnerabilities or just used my own scripts. The tools I used were the scripts that I've showed you for getting the different code bases. And then I used Sublime Text. and that is more or less what I use. Yeah, there's a few different tools for PHP specifically for finding vulnerabilities, but they are really bad. So you're probably better off sort of making up your own process that you like rather than trying tools that are not well maintained. Sorry? So all the scripts you just saw, I will be releasing. I managed to lock myself out of a remote desktop at home, so I'm unable to fetch the files right now. I was going to put them up this morning, but I'll put it up next week, and a presentation.